Hi all, I am Leo Prabhu. Let us see about ratio of tensions. The ratio of tensions, it purely depends on the coefficient of friction between the belt and the pulley and the angle of lap on the pulley. Ratio of tensions for flat belt drive. Consider a driven pulley rotating in the clockwise direction as shown in the diagram given below. Let T1 be the tension in the belt on the tight side and T2 be the tension on the belt on the slack side, and theta be the angle of contact in radians, that is angle subtended by the arc AB along which the belt touches the pulley at the center. Now consider a small portion of the belt PQ subtending at an angle del theta at the center of the pulley. The belt PQ is in equilibrium under the following forces. The tension T in the belt at P, the tension T plus del T in the belt at Q, normal reaction Rn, and frictional force F is equal to mu into Rn, where mu is the coefficient of friction between the belt and the pulley. Resolving all the forces horizontally and equating the equations, we get normal direction, that is Rn is equal to T plus delta T sin delta theta by 2 plus T into sin delta theta by 2. Let us consider this as the first equation. Since the angle delta theta is very small, therefore putting sin delta theta by 2 is equal to delta theta by 2 in the above equation. Rn is equal to T plus delta T delta into delta theta by 2 plus T into delta theta by 2 which is equal to T into delta theta by 2 plus delta T dot delta theta by 2 plus T into delta theta by 2. By adding all the three terms, we get T into delta theta. Here we are neglecting the term delta T into delta theta by 2. Now consider the above equation as equation 2. Now resolving all the forces vertically, we have mu into Rn is equal to T plus delta T into cos delta theta by 2 minus T into cos theta delta theta by 2. Let us consider this as equation 3. Since the angle delta theta is very small, therefore putting cos delta theta by 2 is equal to 1 in the above equation. Mu into Rn becomes T plus delta T minus T, which is equal to delta T, or it may be written as Rn is equal to delta T by mu. Equating the values of Rn from the equation 2 and 4, T into delta theta is equal to delta theta by mu, or it may be written as delta T by T is equal to mu into delta theta. Integrating both sides between the limits, that is T1 and T2 from 0 to theta respectively, we will get integral T2 to T1 delta T by T is equal to mu into integral 0 to theta delta theta. We get log T1 by T2 is equal to mu theta, or it may be written as T1 by T2 equal to e power mu theta. This is taken as equation 5. Equation 5 can be expressed in terms of logarithm to the base 10, that is 2.3 into log T1 by T2 is equal to mu into theta. The above equation gives the relation between the tight side and slack side tensions in terms of coefficient of friction and angle of contact. Ratio of tensions for V belt drive. A V belt drive with a grooved pulley is given in the diagram right side. Let R1 be the normal reaction between the belt and the sides of the groove. Let R be the total reaction in the plane after the groove. 2 beta is equal to angle of the groove. Mu be the coefficient of friction between the belt and sides of the groove. Resolving the equations vertically to the groove, we get R is equal to R1 sin beta plus R1 sin beta is equal to 2 into R1 sine beta. Now the equation can be written as R1 is equal to R by 2 sine beta. We know that the frictional force F is equal to 2 mu R1, that is 2 mu into R by 2 sine beta, which is equal to mu R by sine beta equal to mu R cosecant beta. Consider a small portion of the belt as the given diagram, subtending an angle delta theta at the center. The tension on the one side of the belt will be T, and the other side T plus delta T. Now proceeding we get the frictional resistance equal to mu or cosecant beta instead of mu r. Thus the relation between T1 and T2 for the V belt drive will be 2.3 log T1 by T2 is equal to mu theta cosecant beta. Ratio of tensions for rope drive. The ratio of driving tension for the rope drive is derived in the exactly in the same way as in the V belts. That the ratio of driving tension for rope drive is 2.3 log T1 by T2 equal to mu into theta cosecant beta, where mu, theta and beta have usual terms. Thank you.